Good day everyone. Welcome to another episode of Learning Mathematics. For this lesson, we will be learning about circles, specifically chords, arcs, angles, tangents, and secants. Before we will move further, let us recall the important parts of circles. Let me get the first figure. Alright, we have here, this is the center of the circle. So this circle is called circle O. Please be reminded that circles are named after its center. The important parts are, this is the radius. And this line here crossing the center is called diameter. Half of the diameter is the radius. Times 2 of the radius is the diameter. Another important part of the circle is the chords. A chord is a line segment whose endpoints lie on the circle. And this one is an arc. Another thing is the central angle. The central angle is an angle whose vertex is the center of the circle. So this is the central angle. Another angle is the inscribed angle. This one is an inscribed angle. An inscribed angle is an angle whose vertex is on the circle. This is the vertex of this angle. Another important part is the tangent. This one is a tangent. A tangent is a line segment or a ray which touches the circle at exactly one point only. Another is secant. This is an example of a secant. It's a line segment or a ray which touches the circle at two exact points. These 2 points here. Now that we have discussed already the important parts of the circle, let us proceed to the different measurement or relationship among the parts. Please take note that the concepts or the relationship that I'm going to discuss are backed up by different postulates, theorems, and corollaries. To make it easier, I'll just simply discuss by showing illustrative examples instead of stating the different postulates, theorems, and corollaries. So let me get another figure. Alright, the first relationship among central and inscribed angles and arcs. So we have here, if this is point A, we call this circle as circle A. If we're going to name this point as point B, and this is point C, this is a central angle. We call this, please remember how to write the angles properly or name an angle properly using using the vertex or three points of the angle. So we have here angle A, B, C. This is a central angle because the vertex is the center of the circle. Accordingly, the measure of this inscribed or central angle is equal to the measure of the intercepted arc. This is the intercepted arc of angle ABC. So intercepted arc of angle ABC is arc BC. Again, the measure of the central angle ABC is equal to the measure of the intercepted arc BC. Therefore, if this is 65 degrees, therefore, arc BC is also equal to 65 degrees. That's the first concept. Let's proceed to the next. Let me get another figure. So we have here several or two diameters intersecting at the circle. So it formed several central angles. Let's identify the relationship among the different angles formed by these two chords. So if we're going to name this as point O, this is circle O. Let's name the points A, B, C, and D. So let's pick up, for example, this central angle and this central angle. So we have angle COD and angle AOB. Accordingly, if these two central angles are congruent, so angle COD is congruent. Please take note of the symbol for congruent. Congruent, this angle is congruent to angle AOB. Then, the intercepted arcs are also congruent. So, arc CD is also congruent to arc AB. Similarly, if these two arcs here are congruent, then the corresponding central angles are also congruent. Okay, let's proceed to the next relationship. Let me get another figure. It's the wrong figure. Let me get another one. Okay, this figure. Please take note that this chord here is not the diameter because it did not pass through the center. So let's name the points here. We have, if this is O, this is circle O. Then this point is O. Let's name this point as A, B, C, D, and E. And then let me draw a line. Sorry. Let me draw a line from this point to that point. So, supposing that there's a line here. Now, accordingly, the relationship between the angles formed here and the arc is that this angle here is an inscribed angle. So, if angle AB is an inscribed angle, then its measure is equal to half of the measure of the intercepted arc, which is arc AB. Again, for this figure, or for the inscribed arc, for the inscribed angle, the relationship between its intercepted arc is that the measure of this inscribed angle is half the measure of its inscribed arc. So, for example, if this is 120 degrees, if arc, let's just say arc AB is equal to 120 degrees, therefore, the measure of angle AEB is equal to 60 degrees because it's half. Another example, this is an inscribed angle as well. So if this arc here, if the measure of arc EC is 80 degrees, then the measure of angle EAC is equal to 40 degrees. Please note that there are two inscribed angles intercepting this arc. Take note of this arc. This angle and this angle as well. Because these two angles are intercepting the same arc, therefore, angle AAC and angle EBC are congruent, right? Because they're intercepting the same arc EC. Let's proceed to the next figure. We have here an inscribed polygon. Inscribed polygon, if all the vertices of that polygon lie in the circle, and this polygon is a quadrilateral. Quadrilateral is a polygon having 4 sides. Again, a polygon is inscribed if all its vertices lie on the circle. So these are the vertices of this polygon, quadrilateral. So this quadrilateral here is inscribed in a circle or an inscribed polygon. So let's name the points A, B, C, and D. Let's name this circle as circle M. So let's proceed to the relationship among the angles here. It is said that if a polygon is inscribed or a quadrilateral is inscribed in a circle, the opposite angles, so this angle and this angle, are supplementary, meaning it is equal to 180 degrees. Therefore, if this is 80 degrees, let's just say 80 degrees, this is 100 degrees because they are supplementary. And take note that supplementary angles are two angles whose sum of their measures is 180 degrees. So if this is 50 degrees, therefore this is 130 degrees. This also sums up to 180 degrees. Okay, let's proceed to the next figure. Let's have the relationship among chords, radii, and arcs. Let me get another figure. Okay, so here the relationship we can derive is of the radii or the radius and the chord which is perpendicular to the radius. So if this is A, this is B, C, D, and A. Take note that line segment AD is a radius and line segment BE is a chord. Now, one of the relationships among these chords or the radius and the chord is that if this radius is perpendicular to a chord, this is perpendicular, it forms a right angle, then this radius is a bisector. It bisects the chord and the intercepted arc. So this line segment AD bisects chord BE and arc BDE. What is the meaning of bisector? It bisects or it divided the chord into two equal parts. So if this chord here measures 12 centimeters or 12 inches, therefore from this point to here it's only 6 because it is divided into two equal parts. That's the meaning of bisector. Similarly, if this arc here is 50, therefore from this point to this point it becomes 25, and from this point to this point as well as also 25. Okay, so using this data, for example, if this is 5 inches, so we have here a right triangle. Now we can solve for this side using the Pythagorean theorem, which is c squared is equal to a squared plus b squared. Okay, so if you're going to solve few problems, now you can apply the concept of right triangle. Now let's proceed to relationship among chords, tangents, and secants. Let me get the last figure. Okay, so we have here tangents and secants. Let us name first the circle. If this is A, so we call this circle A. We have B, this point here is B, this is C, this is D, E, F, G, H, J. Okay, we have a tangent here, this line here, line DB is a tangent. This one is a secant, this is a secant, 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 this is a tangent. So there are angles formed by two secants, two tangents, or one tangent and one secant. These are the relationships among those chords, tangents, and secants. Now, let's just take this angle. It is according to the postulates, theorems, and corollaries, the measure of this angle is half the measure of the sum of the intercepted arcs. Take note that there are two arcs intercepted. This arc here and this arc here are intercepted. So if we're going to get the measure of this angle, for example, if this is 25 degrees and this is 75 degrees, therefore angle HJI is equal to 50 degrees. Why 50? 25 plus 75 is 100. Divided by 2 is 50. Alright, let's have another angle. This one here is not, we're going to get the measure of this arc and this arc. But it's no longer half of the sum, but half of the difference. So this arc minus the measure of this arc is equal to this angle. Now let's get another angle. This one here, the measure of this angle is equal to this, or half of this, and this arc, big arc, which the angle is intercepted. Alright, I hope you're learning something, and that ends our lesson for today. Don't forget to subscribe and hit that notification bell. Good day, everyone.